random variables. So the premise here is that based on some probability model, the mean of x, which is of course also known as the expected value of x, the standard deviation of x, the mean of y, and the standard deviation of y have already been calculated. X and y are independent variables. So we have these notations, and just we can use the sigma notation, we can use the expected value notation. You'll kind of see a little bit of both of them. They're independent of each other. So x and y define some probability models. One might be for children, one might be for adults. They all represent something. Now in today's, we're not talking about applications. We're already going to be doing it. Now something we're already going to be giving them. We're going to be given the mean. So we are given these today. All right. Now, something else to note, the variance is what we will refer to as var. And so the variance, variance of x, we'll write it as var x. And the variance of x is the summation, is the standard deviation squared. Now this is going to be very important for one of the works that we have done today. And so also it can be found that the standard deviation of x is equal to the square root of the variance right there. So that's one of the most important notations. You might see that when you look at your homework solutions. Basically, if we can do everything without that VAR, it's more helpful. But we will make sure that we know how to do it. So, rules. Of combining random variables. Expected value mean are calculated just as you would think. All right, so remember when we did way back when, like in chapter 5, and we added a bunch of stuff to the data. The calculation of means, which is also expected value, does not change. And what I mean that is that if we take some variable x and we lose $4, which can also be written as e of x minus 4, then the answer to this is e expected value of x minus 4. Now, what I would mean in this example, and like I said, tomorrow we'll talk more about what it means, what the meaning of this is. But for example, x represents the revenue, and it cost $4, and so the profit is equal to x minus 4. So if I want to say how much do I expect to get, I would take the expected value and subtract 4. And this gives us our first major rule, and it is that the expected value of x plus or minus a constant is equal to the expected value of x plus or minus that constant. Expected value works exactly like you would think it would. Okay. I'm gonna go through all the the mean of x plus y works exactly like how you would think it would work. The expected value, if I take two variables, you would do exactly what you would think you would get. You take the expected value of the x and you add to it the expected value of y. And what this means, for example, if x represents cost number 1 and y represents cost number 2, then the total cost is x plus y, and which means that we would just add the two expected values. How much do I expect the first one to cost on average? How much do I expect the second one to cost on average? And I add them. And that gives me the rule that the expected value of x plus or minus y, remember y being a variable, x and y, c is for constant, is equal to the expected value of x plus or minus the expected value of y. Nothing crazy there with expected value. If complete the same action multiple independent times, we note each time as x1, x2, x3. Now, first and foremost, the expected value of x1 is just the expected value of x. The expected value of x2 is just the expected value of x. The expected value of x3 is the expected value of x. And what the rule says is that the expected value of x1 plus x2 plus x3 is equal to the expected value of x plus the expected value of x plus the expected value of x, which makes sense that we would get 3 expected value of x. As such, the rule here is that the expected value of x1 plus x2 plus dot 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 plus x to the n is equal to n times the expected value of x. If you do something 100 times, if the expected value is that you're going to win $1, now you might lose some, you might win some, you might win more than $1, lose a lot more than $1, and so forth. But if the expected value was $1 and you do it 1,000 times, you would expect to earn $1,000. All right. And finally, the other rule is that if we, the idea here is that if we multiply by a constant, we get the expected value of a times x, which is just the constant times the expected value of x. For example, x represents some cost. So x represents number of people, and a represents the cost per person. Therefore, AX represents total cost, and that's what we have. Now, note on this part right here, we are not completing X and times. We are multiplying the cost of X by N. So it's slightly different. Now, if you look at the formula, it's exactly the same. All right. So it turns out that the formula itself is the same. So expected value just works like how you would think it would work. That's the main premise here. Expected value works like expected value. As such, we can do what is known as linear transformations of means, and basically what this means is that if I take the mean of AX plus BY, then I get A times the mean of X plus B times the mean of Y, plus or minus. So with means, it works exactly like you would do. So for example, if I told you that the mean of X was equal to 5, the standard deviation of X was equal to 1. And I know I was actually planning on doing a standard deviation, but with such a short time, I really need a lot more time to focus on standard deviation. So I'm going to give it to you right now, but we're not going to use it. And the mean of Y is equal to 3, and the standard deviation of Y is equal to 2. If I had, and this is how kind of like your homework will look, if I had like 2x minus 3y, and I want to find the mean of that, then the mean of 2x minus 3y is exactly like I would think it would be. It would be 2 times the mean of x minus 3 times the mean of y. So in tonight's homework, and also we're going to do it as tomorrow as well, because we just need to let you learn the process. But the basic idea here is that X, and we'll talk about applications. I was going to do applications tomorrow, but I'll shift that to Thursday. The premise here was that, if X represents some very random variable that has this mean and this X. Now, we will also be working with problems where I will give you the probability models, and you will have to utilize a probability model to find the mean of X and the mean of Y. And then or the mean of X and the standard deviation of X. So you might be given a problem. This is how a typical AP exam problem works. You're given a probability model for X, the table, and you go about calculating that mean of X and the standard deviation of Y. That's the first question. And then they just tell you the mean of Y. Here's the mean and standard deviation of Y. And they then ask you about some type of combination. and say, oh, you're going to have two x's, but you for every x you earn $2, but for every y you lose $3. How much do you have in the end, or how much would you expect to have? What would be the mean? And they'll also ask you for the standard deviation. And so when I do this, I get 2 times 5 minus 3 times 3, which is 10 minus 9, which would be 1. Units if given. So we're going to keep the homework straightforward tonight, and that in the problems that I've assigned for homework, only calculate the mean. All right. So ignore the one with the standard deviations. We're going to talk about these standard deviations tomorrow. Now I'm ending class with the material a little earlier for multiple reasons. All right.